So I'll put your seating chart back up in just a minute if you can't remember where you're supposed to sit. Where the heck was that live stream? Oh, here it is. So I'll put your seating chart back up in just a minute if you can't remember where you're. I'll turn this off in just a minute. Come on. I'll put your seating chart back up in just a minute if you can't remember where you're. I'll turn this off in just a minute. All right. Right here. Do you have any idea? Do you remember it all? Oh, okay. Yep, there you go. So if you can't remember yours, it's up here. Oh, okay. And if no one else shows up, I don't mind if you distance more. I just don't want to take people's seats away who have it. So if you can't remember, I have the seating chart here. Much more than the 7 people who came on Thursday last week. All right, so let's get started. Before I begin, just a couple of items. The first is today we're going to talk about elasticity of demand and hopefully finish elasticity in total revenue. This week we have 2 assignments due, the Chapter 3 SmartWorks homework and the Chapter 4 Inquisitive. And someone asked me, do I have to wait till Thursday to do them? No, just because it's due on Thursday doesn't mean you have to wait till Thursday to do it. For example, we've already completed Chapter 3, so you're more than welcome to do the Chapter 3 homework. And Inquisitive is designed so that you work on it before actually going over it in class. It's actually designed for you just to kind of read over the chapter and then go over it. So you can even do the Inquisitive, even though we're just starting Chapter 4 today. You're more than welcome to do it. And hopefully you're familiar with Inquisitive by now. You know the questions are not the same as the SmartWorks, which are a little more, in my opinion, difficult. Would you guys agree with that? Okay. So anyway, in short, you're more than welcome to do the homework assignments early. Heck, you can do them all today if you want. You can go up to Chapter 12 and do it. I don't think you should, but you could. We're going to have a quiz not this Thursday, but next Thursday on the 17th. All right, I'll give you more details. It's going to be over Chapters 3 and 4. The first quiz was primarily over Chapters 1 and 2. This quiz is going to be mostly over actually exclusively over Chapters 3 and 4. But not till next week. I will not have in-person classes on Thursday night 10. All right, I'm actually going to do an online conference. It'll be interesting. I've never done an online conference, so I'll be watching people give presentations on Zoom. And I will be giving a presentation on Zoom myself, and one of my colleagues is actually doing it as well, or former colleagues. So I will post a little bit extra of an online lecture, though. All right, so remember, you're supposed to watch both the online lectures and the in-person lectures, but there's going to be a little bit more online lecture since we're not going to have an in-person lecture. So instead of the usual 25 minutes, it'll probably be 50 to 60 minutes. So keep that in mind. And just watch it during the time that you would be in class anyway. That way it's like you're not missing class. And I've had some discussion on Quiz 1. I know a lot of you struggled with Quiz 1. We had some great scores. I'm not saying no one did great. We had perfect score even, all right? But I know some of you struggled, and that's okay. First off, I want to say that's not unusual. Oftentimes, people don't do as well on my first quiz. It just gives students an idea of what kind of questions I ask. I was talking to a student this morning, actually in my office hours, saying, well, when I took macro, everything was multiple choice, and you could kind of use that to figure out the answers. Right? Not all my questions are multiple choice. And I do that because I think you actually learn the material better that way, sometimes with short answers. Ideally, I'd like to give you graphing questions, but unfortunately, there's no graphing app in Blackboard, so I have to give you short answer, input, fill in the blank essentially, or multiple choice, or true false. All right, and I kind of give a mix of all of those things. All right, so you know, if you didn't do so hot in quiz 1, it's only 20 points. The exam, just a minute. The exams are only worth, the quiz are only worth 20. Right, that's as much as just a week of homework. But make sure the exam, which is going to be the same types of questions as the quiz, it's going to be like 3 quizzes, because instead of 10 questions, it's going to be 30. You are prepared for it. All right, because if you can do well on quiz 1 and quiz 2, or at least you could now after we go over it next week, then you'll be ready for exam 2. Yes, go ahead. Exam 1, excuse me. I answered your question? Yeah, I'm going to talk about it. There's some people who haven't taken it. That's why I'm not doing it today. Because if I go over it and put it on live on YouTube, then that, you know. Okay. Other questions? All right. So let's begin. Today we're going to start talking about Chapter 4, which is elasticity. Elasticity. And let me move the camera here really quick. I'll come back to that, don't worry. Or you can see me, so that now everyone can see me on camera. Now, I'm taking off my belt for about half of you. Oh no, this thing's stuck. Not used to this microphone here. I was gonna put it on my pants. It was on my belt. Myself, there we go. All right, for those of you who are worried, don't worry, I'm gonna stop at the belt, okay? For those of you who are excited, don't get too excited because I'm stopping at the belt, all right, which is about 50-50 probably. Now, why did I take my belt off? Well, I picked these pants today because they have an elasticity band. You see how I can pull it out a little bit? Some of you, especially after the holidays, when you put your jeans on, you can't do that at all, right? I mean, it's just like you got to struggle to get in. There's no give on a lot of jeans, right? There's no elasticity band. But pants have an elasticity band. It means that you can gain weight and the pants will adjust with you. While your jeans don't have an elasticity band, if you gain weight, you can really try to suck it in and button it. But at some point, it's just going to burst out, like those old Subway commercials. I don't know if you guys remember those. People would gain weight and it would show the button pop out. All right, so it's kind of a fun story of elasticity. And one time I learned the hard way after the holidays. In economics, we give all of our, at least we did, who knows what's going to happen this year, but all the job market is on one weekend after the new year. Why? Because we're economists. That's when hotels have the cheapest rates, because everyone's done traveling after New Year's typically and going back to work. So we have but the academics typically have that extra week. And so we use that week as our big conference. And it's not only just a conference, it's a giant job fair and a training fair. And it's basically the biggest thing. It's the AEA session. The point is, I once had a suit that I fit perfectly in before November. And then before I left, I tried it on again and I couldn't get it on. I had to take it to get it fixed. And so those pants were not responsive. I couldn't wear them. I had to get new pants because it didn't have that elasticity band. All right? So why is elasticity interesting? It's interesting in terms of weight, but why is it interesting for you? Elasticity can teach you how to make money. All right? Some of you might want to start your own business, and you want a product that's going to sell. You want a product that you can raise the price of and not lose most of your customers. All right, so elasticity is going to tell us about making money, it turns out. All right, if we know our demand is very inelastic, we're going to be able to raise our price high. But if our demand is elastic, and don't worry, I'm going to get back into this. You don't have to write this down yet. We're going to go through this today. You're going to want to actually lower your price in some cases. In some cases. All right, so elasticity isn't just useful in terms of thinking about weight control, but it's also useful in economics. Now let's see if I can get back. Let me get the camera back. And the camera is not responding. It's moving very slowly. Sorry about that, guys. For some reason, the camera... Oh, I see. A little faster. Camera moves really slow when coming back. I'll have to keep that in mind. Sorry, guys. You can't see me, but I'm actually just moving the camera. I don't know if you can see that move or not. It's moving very slowly. Not anymore. There we go. Oh, come on. There we go. Let's see that now. There we go. Almost done, guys. I don't know why one of the presets isn't just the screen up there, but okay. All right. So we're going to be talking about price elasticity of demand. So first off, I'm going to give you the definition of elasticity. There's going to be 3 definitions. There's an intuitive definition, a verbal definition, and I'm going to give you the actual mathematical formula. I want to say, though, for the mathematical formula, there's a couple problems in SmartWorks, but you're not going to have to do those problems on the quiz or exam. All right, I'm going to make your life easy. So what's the intuitive definition? Intuitively, what does elasticity tell us? It tells us the degree of responsiveness of quantity demanded to a change in price. In other words, how responsive are consumers to price changes? So think about some goods, for example. EpiPens. Who knows what an EpiPen is? Quite a few of you. Want to volunteer? Right. It prevents you from going into shock. All right. I'm just going to put it in the short way, but you had a much better answer. Is that something that people say, you know what? I don't want that because they raise their price 10 cents. No. Right? So people are not very responsive to price changes for those types of goods, right? And we'll get to what types of goods later, but I just want to give you an idea of what I mean by responsiveness. Now think about something like a pet rock. If pet rocks double in price, do you still need that pet rock? No. All right, so some goods, consumers are going to be more responsive to price changes than others. All right, it is technically the percent change in quantity demanded divided by the percent change in price. Mathematically, it's the negative percent change in quantity demanded divided by the percent change in price, and I'll get to the negative in just a moment. But before I get to the negative, I want to note elasticity has no units, which is actually a good thing. If you remember maybe in some of your classes, something looks like it's a really big effect when you put it in ounces, but then when you put it in gallons, it doesn't look like it's that big of an effect. So that's why elasticity has no units, all right? Because we don't want to just change the unit and then have a different answer by changing the unit. So elasticity has no units. Why is there that negative there? What direction, by the law of demand, what is the relationship between price and quantity demanded? Anyone remember? What is the relationship between price and quantity demanded by the law of demand? They move in the same direction, opposite direction? Yes. Negative. They move in opposite directions, right? And so if we didn't have this negative sign, this would be a negative number because they move in opposite directions. Well, economists are lazy. If elasticity of demand is always negative, I don't want to write the negative sign every time. So what's the negative of a negative? A positive, right? So even though you can think of elasticity of demand as negative, economists are lazy, so they write it as a positive number. All right, there's going to be other elasticities when you watch the online lecture or listen to the online lecture on Thursday where they can be negative, and it actually has a different meaning. But for elasticity of demand, which we're talking about today, and elasticity of supply, which I've already posted, which will be available, they're always going to be positive. Elasticity of supply, that makes sense because they always move in the same direction. You don't even need a negative sign. But for demand, we just put that negative there so that the negatives can cancel and we have a nice positive number. All right? There's going to be 4 types of elasticities we're going to look at. We're going to look at elastic goods first, followed by inelastic. I'm going to talk about unitary elastic, but I won't actually cover it. And then I'm going to actually draw the extremes. All right, so the first good is elastic demand. So intuitively, what does it mean for demand to be elastic? It means consumers are responsive to price changes. I want to make sure people who are watching YouTube can see, so that's why I kind of slowed down. Consumers are responsive to price changes. Using our formula, which I just had up, what it means is the percent change in quantity demanded, or the absolute value of it, because I'm not going to put the negative signs, just think about the absolute value, because I don't want to deal with negatives. But the percent change in quantity demanded is going to be bigger than the percent change in price. So for example, the percent change in quantity demanded might be 10, but the percent change in price might just be 5. So the price went up 5%, but I lost 10% of my customers. Right? Consumers are very responsive, right? Even though the price went up just a little bit, you lost twice as many as the percent increase in price. Or conversely, same thing with going down. If the price went down 5%, we only gained 10% more customers. Now, if I divide both sides, I know this math is difficult. If I divide both sides by the percent change in price, and remember your algebra here, what am I going to get on this side? 1, thank you. So what this tells us is the elasticity of demand, which I'm just going to write as ED for short because I don't feel like writing it, is greater than 1 when demand is elastic. All right, so when demand is elastic, this number is bigger than 1. This number is bigger than 1. Important, but not as important as the next thing I'm going to show you. Because we are going to graph elastic demand. All right, I'm going to see a few of you still writing, so I'll wait a minute. But I'm going to graph it. I want to say something. First off, we're going to stick with lines because lines are easier. I could give you curves, but you'd hate me for it. Just like with PPCs, I could have given you curves, but it would have made your life a nightmare. We're going to stick with lines. There is one problem with lines, and that is the elasticity at every point on a line is different. And why is that? I'll talk about that more in just a minute. But the reason I say that is a line is never totally elastic or totally inelastic, okay? But some lines are going to be more elastic than other lines. Some demand curves, in other words, are going to be more elastic than other demand curves. Everyone have this down so I can draw it and show you what I mean? So what do I mean? So it turns out if we have elastic demand, remember, this means consumers are responsive, all right? So I'm going to graph elastic demand. Don't forget to label your axes. It turns out it's going to look like this. It's going to be flatter. And I'll show you why in just a minute. Suppose this is the initial price, P1. And the firm raises its price just a little bit to P2. So this is demand for a particular product. This is Q1. And this is Q2. So P went up a little bit. Price went up just a little bit. But what happened to quantity demanded? Did it go down just a tiny bit? No, it went down a lot. Right? So elastic demand curves tend to be flatter. And I write 10 because technically curves have different elasticity at every point. But when I say draw elastic demand, I want you to draw a flatter curve. Don't draw it perfectly flat. We'll talk about that in a minute. I still want you to have the law of demand. It's still downward sloping. So notice what I have here. It's still downward sloping. It's not perfectly flat, but it's flatter. Now, why is it that they don't have the same elasticity at every point? Because lines behave weird at the end point. When you have prices of 0 and you go up just a little bit, technically it infinitely increased percentage-wise sometimes, right? So lines behave kind of weird at endpoints. And you know, a demand curve is going to have an endpoint here and an endpoint somewhere down here at the other end of this graph. I don't want you to worry about that. All right? I'm not telling you to confuse you. I'm telling you not to worry about it. Just for the sake of this class, you hear the word elastic demand, think a flatter curve. Okay? Think a flatter curve. Any questions about that? All right, so that's elastic demand. So what is inelastic demand? Well, inelastic demand means consumers are not very responsive to price changes. So again, inelastic demand means consumers are not very responsive to price changes. And so mathematically, this is going to mean the percent change in quantity demanded, or again, technically the absolute value, but I'm not going to write it, is going to be less than the percent change in the absolute value of price. Again, I'm not writing the absolute values, but you can think of it being there if you want. So for example, if the percent change in quantity demanded is 20%, perhaps the percent change in price is 40. So the firm raised its price 40%, but it only lost 20% of its customers. Or it lowered its price 40% and it only gained 20% more customers. So I want to divide both sides by the percent change in price. So here, this is again elasticity of demand. What's this number? Anyone remember? What do you get when you divide a number by itself? Hopefully you're 1. So this means elasticity of demand is less than 1. So with elastic demand, it was bigger than 1. With inelastic demand, it's less than 1. So before, consumers were, before the graph was flat. So what do you think the graph is going to look like now? Go ahead. Steeper, yeah. I think that's the word. Yeah, you're right, but steeper, sort of. Instead of like this, it's like this. So I guess for those of you watching, instead of like this, it's going to be like this, right? Everyone have this? So what does that mean about the graph? Well, inelastic demand is going to tend to be steeper, as I said. We'll draw it again just to make sure you guys understand it. Oh no. Forgot to hit the record. Inelastic demand tends to be steeper. Don't forget demand slopes downward. I raise my price a lot. Quantity does not change very much. All right, for those of you watching the recording, I forgot to hit record, so I will put the rest up after on a separate video. So make sure you listen to the other recording first. So inelastic demand tends to be flatter. Steeper, excuse me. I drew it right, but I said it wrong. Tends to be steeper. Again, technically the endpoints, things are weird. But it tends to be steeper. Now, I want to draw the two extremes. Well, actually, before I do that, I want to talk about unitary elastic. I won't actually draw it. Unitary elastic, can anyone guess what it means? What's the only condition we have left? We have greater than and less than 1. What's the only other condition you can possibly have? Equal to 1. So unitary elastic means it's equal to 1. But as I said, on a line, elasticity changes at every point, so we cannot draw a point with unitary elastic, or a line with unitary elastic. It just doesn't make sense. I suppose you could think of one that's at a 45-degree angle that way, but we're not going to do unitary elastic. I want you to think of goods as either elastic or inelastic. All right, but unitary elastic is just the case where they're equal to each other. Percent change in quantity demanded equals to percent change in price. All right. So now I want to talk about the two extremes. So we have perfectly elastic demand and perfectly inelastic demand. Perfect elastic demand we actually are going to use in this course, and I'll talk about what we use it for. Perfectly elastic demand is just a horizontal line. What does this mean? So we're going to use this later in the course when firms behave as price takers. What that means is they're never going to want to lower the price below the market price because they can always sell their good at the market price. That's why it never goes, they're never going to charge below this price. So you think about this as a market price. They're never going to charge anything above that price because then no one would buy their product because they could always buy it from someone else at the market price. All right, so this is kind of a weird demand curve, but we actually are going to use it. We're not going to use it we're going to use it very much in one chapter, not for a while, but we are going to use it. The next one is maybe a bit more intuitive. Which is perfectly inelastic demand. It's just a vertical line. So something like kidney dialysis machines. What happens if you don't have a kidney dialysis machine? Anyone know anyone on dialysis? What's going to happen if you don't have a dialysis machine? You're going to die. So the demand for kidney dialysis machines is going to be, if not vertical, pretty dang close. Now, a good can never have perfectly inelastic demand forever. The reason is, remember, there's two components of quantity demanded. It's willingness, but what was the other one? What's the other important thing? You have to be able to afford it. Right? Eventually, if the price is high enough, can you afford it? No. So eventually, all demand curves are going to cut back somewhere. But it's possible that there could be a portion of the demand curve that is perfectly inelastic or very close for something that is necessary to live. In other words, you're going to pay any price you can to have that good. I'm not saying it's a common demand curve, but it's certainly for some goods you might think that that is true. All right, so I've talked to you about this property elasticity, but I haven't told you why it's useful yet. It's useful because it's going to tell us about total revenue. So what is total revenue? You guys, most of you raise your hand if you're a business major. All right, so a few of you, quite a few of you. Not as many as I expected, but quite a few of you. What's the formula for total revenue? Okay, profit has two components. What are the two components? Total revenue is one, and cost or expenses, all right? We're going to talk about cost later in the course. In fact, we're going to have a whole unit just on cost. Right now, we're talking about total revenue. That's the first component, right? How much money you bring in. And how much money you bring in if you charge each customer the same price as what? Total revenue is equal to simply the price times the quantity, right? The price you sell your good at times the number of people who buy it. So if I sell 5 goods for $10 a piece, what's my total revenue? $50. All right. Is that obvious now that I show it? You guys know what I mean by total revenue now? So it turns out elasticity can tell us about total revenue. There's a relationship between the elasticity of demand curve and how much total revenue a firm earns. All right. So I'm going to draw a picture with elastic demand. So hopefully you all remember, what is that demand curve going to look like? It's going to be flatter. Good. Draw P1. Man, I went off the graph. Let me draw. Sorry about that. Let me draw another graph here. It's so much easier on the board when you can just erase something. Yeah, what's your question while I'm redrawing this? Yes, so someone just asked, in short, is there a shorter way to say what elasticity is? And that is, yes, how responsive consumers are to changes in price. And companies really care about it because they want to know how much money they can make with their total revenue, all right? And we'll talk about what type of products are going to be more elastic and more inelastic. I don't know about today, but on my online lecture if I don't get to it today. All right, so I'm going to draw a really big graph so that doesn't happen again. I don't use pencil because pencil doesn't turn out so well in the recording. All right. So we have a flatter demand curve. And let's say this is P1 and this is P2. So this is Q1. And this is Q2. Believe it or not, total revenue is actually in this graph. I'd say, well, I don't see total revenue. Put on your geometry caps from high school. Anyone see where total revenue is in this graph? I'm going to call this box A, this box B, and this box C. Does everyone see the total revenue of P1 equals B plus C? Everyone get it now? The area of a rectangle, right? So this box has length Q1 and height P1, right? So the area of this box right here is the total revenue of P1. The total revenue of P2 is A plus B. Everyone see that? What is the relationship between A and C? Just looking at it, what's the relationship between A and C? Right, it's easier than you think. If I went to my 4-year-old son, I said, what's the relationship between this rectangle and this rectangle? What would he say? No, between them. So he would just say, C is bigger than A, right? Everyone see rectangle C is bigger than rectangle A? So what does that mean? If C is bigger than A, what does that tell you about total revenue? Is it higher with P1 or P2? TR is higher with price 1. So is it always good to raise your prices as a firm? Some people always think that, well, cost went up 10%, we'll raise our price 10%. Not necessarily. Maybe, maybe not. Yes. That's what I'm doing. Then I have to give you numbers. So what's nice about this is I don't have to give you numbers. This is true for every number. If you want to do that, you're more than welcome to. I want you to understand it. So if that helps you understand it, put specific numbers in. All right, but I think that would make things worse because then I'd have to give you a demand curve equation. Then you have to figure out the numbers with the demand curve, etc. So this is just my philosophy, is this is not a math course, right? And if I make you solve equations, it'll be more like a math course. I try to make it as unmathy as possible. There's lots of graphing, which is still mathematics. I know some people are better with tables than graphs, and you can do this with tables too. Maybe, I think there's some examples of the book with tables where that might be better. And you can see, in fact, maybe I'll do that next class or talk about it in my online lecture. You can do the same thing with tables and see that consumers are more responsive with one demand curve than the other. All right, any questions about this? So in other words, if the demand for your product is elastic and you have zero cost, which there are cases where you have zero cost. If I am in charge of a government toll booth, all the cost is fixed. What is the cost of letting one more car across the bridge, the toll bridge? Almost nothing, right? So if your goal is to maximize profit for the toll booth, and you know that the demand for your toll is elastic, you actually might want to lower your price. You do want to lower your price because you'll make more money with a lower price, and you certainly don't want to raise it. So sometimes costs are actually zero because there's only a fixed cost. So think about this room. It's kind of weird during the pandemic, but let's suppose this wasn't a pandemic. What's the cost of the university of putting a butt in an extra seat if the classroom's not full? Zero. Right? So when universities think about prices, they're going to think about elasticity of demand. Unless they're at capacity, but that's different. Then the cost is no longer zero because when you put a student in that seat, you're kicking a student out. Same thing with airlines. If the plane is not full, the price of putting someone in that plane is zero. Okay? So you can actually use this for lots of goods to determine whether you should raise or lower the price. Because lots of times the marginal cost of adding a person or a customer is zero. Not always. If we talk about a good like textbooks, even though it might be the case that my revenue could go up if I lower the price, my cost might go up for textbooks, right? I actually have to produce something here. So in the case where there's an actual true cost of each unit, just because it's the demand is elastic doesn't mean you want to lower your price, right? Because your cost might skyrocket. Let's look at inelastic demand. All right, for inelastic demand, remember it's going to be steep. I'll call this P1. Q2. And I'm trying to be consistent. Let me see if I can, is it on the back of this? Yeah, so this one will be A, B, and C. So we do the same thing we did before, right? The total revenue at P1 is equal to B plus C. And the total revenue at P2 is equal to A plus B. So you might say, oh, we got the same result as last time, but what's the big difference? What's the relationship between A and C now? Yeah, now A is bigger than C. Before, A was less than C. Now A is bigger than C. So A is bigger than C. So TR is higher at P2. So in this case, you actually want to raise your price. In this case, you actually, whenever you have inelastic demand, you always want to raise your price. Why is that? Well, what happens to your revenue if you raise your price with inelastic demand? What's going to happen to revenue? It's going to increase. What's going to happen to cost? You're producing less. What's going to happen to cost? It's going to decrease, regardless of you're selling textbooks or plane tickets. So if demand for your product is inelastic, you can raise your price and make more money. I say, well, why not raise your price forever? Well, it turns out elasticity is going to depend on how high the price is, so you can't do that, which we'll get to next. But you can see, even if I didn't tell you what makes a good elastic or inelastic, you can see that it's very important to understand whether your product has elastic or inelastic demand, because it's going to help you determine what your price is going to be for that product. What your price is going to be for that product. Now, what determines whether a good is elastic or inelastic? What's going to determine the elasticity of a good, if I can find it? Here it is. Does anyone have a guess? What is going to be a determinant in what makes something, this is number 4, factors that determine elasticity. What is going to determine the elasticity of demand? Yes. Perfect. That is the most important thing, actually. So very good. The availability of substitutes. Why is that? Remember, it's how responsive consumers are to price change. If there's a substitute that's almost exactly the same, so let's think about McDonald's and Burger King, not almost exactly the same, but McDonald's raises the price of its Big Mac. What are a lot of consumers going to do? Go to Burger King or go to Wendy's, right? And so when there's lots of substitutes, firms are going to have more elastic demand, right? So when there's lots of substitutes, it's going to be more elastic. And when there's few substitutes, it's going to be more inelastic. My water bill goes up. Are there many substitutes for my indoor plumbing? No, I could buy a bunch of bottled water. I could go shower at the gym, but it's very inconvenient, right? There's not really a good substitute. So what do you think the demand for indoor plumbing is going to be? Is it going to be more inelastic or more elastic? More inelastic. It's going to be steep, right? If they wanted, they could probably raise the price a lot. Now, there's regulations on that. We'll talk more about that when we talk about market power. But it's going to be very inelastic. All right, I want to just get through these 4 before 3 o'clock. Anyone have any guesses of the other ones? There's 3 more. Habit, but I'm going to have this be 2 things because it really depends. Or need verse 1. Because if you have a habit, it's almost as if it's a need, right? For example, a cigarette, is that something people need? No, but if you ask a smoker, isn't it as if they need it? So I would put habits and need verse 1 in the same category. So if something is a need or a habit, quote unquote, is that going to make it more elastic or more inelastic? The price of cigarette goes up. Is everyone going to quit smoking and start chewing? No. So is that going to mean it's elastic or inelastic? It's inelastic. If it's a want or not a habit, what is that going to mean then? It's going to be more elastic. All right, 2 more. What if the price of gum goes up 10%? Raise your hand if you're going to be up in arms. You're going to reconsider your purchase. I don't see any hands up for those of you watching live or watching the recording. Now, suppose you're buying a car and the price goes up 10%. Might you reconsider your purchase? Raise your hand. Aren't those both wants? Yeah. Don't they both have substitutes? Can't you buy a car from someone else? Can't you buy gum from a different gum person or a different store or different company? Yes. But what's the difference between them? Yes. Perfect. Percent income. All right. So I want to go through this quickly. If it's high, you're actually going to be more responsive to price changes, like in the case of a car. And if it's a low percent, you're going to be less responsive. So that's going to make it inelastic. The last one is time. If it's a long time frame, you're going to be more elastic. You have time to adjust, right? I'll give you an example in just a minute. A short time frame is going to be more inelastic. So let's say gas prices go up. So this is a good example with time. Let's say gas prices go up. Raise your hand if you're going to stop driving your car tomorrow or buy a new Prius tomorrow because gas prices go up. But what happens if gas prices are $4 a gallon for a long time? What might you start doing? Maybe get a new car that's more fuel efficient. What else could you do? Maybe not now, but carpool is usually a good answer. Bikes. Public transit, again, maybe not now the best answer, but still. Walking more, etc. All right, I'll give you an acronym to help you remember these in the future. I'm going to let you go now. If you have any questions, let me know. I'll stick around. And here's the assignments again for anyone who may have joined us late. All right, I will see you on Tuesday next week.